You know, oh no. I need to go flirt with Cecilia. And I'm like, she's married. And he's like, she's still, oh, still he has no shade. He has no shade.
So like, you know how when people send like Slack, they just have like the main picture and then like the people out. Yeah. So I was just going with the picture and just I'm just gonna picture. Like, this is really useful. I like these pictures.
All right. Is this a typical showing? I guess most people are here. Let's get started. So
Not a typical showing. I do not know where everybody is. Yeah, literally.
it's Monday. That's the answer.
Yeah.
So this week's reactive topic is functional programming, which is kind of it's like a hard thing to pin down a little bit. It's a collection of techniques that show up in different languages. So JS has a lot of them. It doesn't have all of them. And like functional programming languages tend towards supporting functional programming techniques, but they don't necessarily support all of them either, and many of them will have some support for imperative coding techniques as well. So let's talk techniques. What are some functional programming techniques that you can name?
Separating your functions into smaller.
Yeah, lots of small functions. What can we say about those functions?
Clearly define and doing very specific things that you can pass to other functions.
Right. There's something in particular I'm looking for. It's like with clear signatures, maybe. So this means that we can, even if we don't have to, we can express the type of a thing. So like, let's say, what's an example of a function signature? Check Sudoku of some board, which will be a bunch of integers, will be a Boolean, for example. What else? What are some other techniques? You've used a lot of them. Yeah. Pure functions, yeah.
What about actions, asynchronous actions?
Yeah, so let's see. Yes, in the sense that thunks are functions that return functions. So yes, basically. Okay, so, and that actually goes along with pure functions. So a pure function, what is a pure function?
Function has no side effects.
Yeah, so function has no side effects. That have no side effects.
Predictable results given certain inputs, you expect certain outputs.
Yeah, always has the same return value for a given input, which means that like the signature, so like completely defines, I shouldn't say completely defines its behavior, but completely captures its behavior. So another way of thinking about this is if we have a, if we were to look at a not pure function, like array push, which takes something, say this is an array of t, it takes a t. This doesn't, or this returns something, but what does it return? It returns something stupid, like the number of things pushed or the number of things in the array. And it also like mutates the array. So we have to articulate that somehow in the signature, right? Like adding new syntax, which we don't generally want to do. So if we were to write a functional version of this, what might we do? I'm using this syntax to indicate that push is a method of arrays.
Oh, good. You could make a copy of it.
Yeah, so push could return call it a list maybe. Could return a new list with that item pushed onto it. And this actually is, what a nice segue. This is actually a library that exists. Yeah, immutable.js. Can you see this? No. So, immutable.js, oh no, what did I do? That's weird. Okay, so immutable is a library that gives us, you can't see that all, can you? Let me do this over here. Pardon the windows. It's Monday morning. Okay. So this library gives us immutable data structures, so we can create a list of some stuff. Oh wow, that's going to be really annoying. And then if we call push, we get back a list that has those things in it, and the original list is not changed. Same thing for map. There's a, I hope there's a map in here. Yeah. So we can create a map of hello world, a key. Maybe I should just do it this way. And then we can perform various map operations on it. We can like set something, so set food bar. We can set deep things. So this is quite useful in reducers. I'm showing you this in part because it's a very useful library for when you're hacking around on Redux stuff in particular. You can set a deep key. So this says set the map at the key foo, set its bar key to baz, and return a copy of all of the maps all the way on the way out. So this is useful if you need to set some deeper part of a state than what you're holding and get copies. The nice thing is this library doesn't actually make copies of everything. It makes copies of the things it has to and then shares the rest of the data structure. Okay, so that's another thing. Immutable data. Because we want to avoid side effects, we generally have immutable data structures, which look like this. Okay. Let's look at an example of using some of these techniques. There's a library called RxJS. Is anyone familiar with it? It's pretty cool. I recommend you check it out because it presents like a different paradigm than one we've seen. It gives you these things called observables, which are like promises, only they can emit multiple times, whereas a promise can only emit once. And observables also have a whole bunch of methods like map and flatten and take while. They actually have maybe a foolish number of operators defined on them, which lets you sort of manipulate these streams of events in order to create new streams of events which hopefully represent what you're looking for. So we're going to implement just the listener part of that. Just the part where at the very end you have this stream and you can call subscribe on it. and that gives you or it takes a callback and then calls the callback whenever something happens to the observable. So let's look at this example. Observable. So let's create this as a class. And it's going to have a method subscribe. And what are we going to do? How are we going to write this? Oh, one thing, observables also have an error chain. So if an error comes down the pipe, it's handled separately and goes to the error callback. Thoughts? So the way we're going to use this is say something like new observable o.emit hello, and before that we'll say o.subscribe console log. And we'd expect this to print hello. If we said o.emit error, we'd expect that to go to error. So that's kind of our test case. How do we make this happen? What's that? Well, where does this... Y'all did pledge, right? I know that that's maybe not very helpful, because that workshop tends to be just an explosion of confusion.
And it was a long time ago at this point.
Yeah. But, okay, so whenever we emit something, we want to call all of our subscribers. So what do we need to have? Right. Right, I mean, Redux actually is maybe even a better example of this, but yeah, Redux implements the same pattern. And then what do we do when we subscribe?
You call them?
Yeah, so, well, no, when we subscribe.
Is that when you push whatever you're given onto, you subscribe to whatever you're going to
Yeah.
listen to, so you push that onto your thing?
Yeah.
But then don't you call all of them, or is that only in Redux?
You don't call all of them in Redux.
What do you call it? Is it in dispatch?
Dispatch.
Okay.
Yeah. So subscribe takes two functions on next, which sorry, so this says subscribe changes this class or changes this instance, and it takes on next, which is a function that takes this type, whatever it is. So whatever the thing that this observable is emitting, on next gets one of those and it returns nothing. On error gets an error and returns nothing.
What's the name of this syntax that you're using?
This is like TypeScript. It's like TypeScript, but has some elements of Swift in it. So you can, using the TypeScript compiler, you can actually write this in the method signature itself, and the compiler will check and make sure the types all align, which some people like, other people find to be irritating. It can prevent bugs. It can also be irritating and time-consuming on its own. Okay, so if we've done this, how do we write emit? Ginny, you said it. for each listener, call listener of item. Okay, cool. And then if we have emit error, I guess we need error listeners, and we can do the same thing. Okay. So now I would like you all to do something. This signature isn't quite right. Subscribe actually returns a function which, when you call it, unsubscribes. So this is different than the pattern we've seen with event emitters or DOM events. There you call something like .off or .remove event listener. Here we need to return something which will, when called, be an unsubscribe function.
Well, Redux does it, but it just returns.
Yeah, Redux does this too, yeah.
It just returns.
So why don't you break off into pairs and go forth and write the subscribe function completely.
Did you Slack us our pairs, or are we just?
Oh, I did not. Let me do that.
Just somebody tell that.
All right, pairs have been slacked.
Too long.
this class that we defined here.
Oh, yeah.
Hi, my partner doesn't seem to be here, but was this recorded?
Yeah.
Cool. Alright, thanks.
Oh, that's our This is like a fancy cardboard VR glasses. Alright. Anything not remote or not
Alright, let's see what these work. Do you want to drive or do you want to navigate or what do you want to do? In which case, that's a perfect reason to do it. Okay. Well, let's solve the easy problem first, right? Like the whole thing about subscribe, return and unsubscribe. Like, do you remember how it's done in Redux? Oh, well, okay, so do you see how we've already set up, I say we, but really Ashley has already set up the subscribe function itself. So it's taking in these new functions, right? And then it's got this array of listeners. And what subscribe does is naturally it's subscribing to like things to listen to, right? So it's pushing into this array of listeners. And of course if it's an error, it does the same thing for that array, right? So if that's how you subscribe, how would you unsubscribe? Like what's the logical kind of like way to do it? The arrays at the moment just like it starts with listening and then whatever array, whatever listener you're given.
What are the listeners supposed to be functions?
Yeah. Do you know like how in dispatch you're getting the means? Like what is it? Well, dispatch is an action, but basically the idea is like what am I supposed to do? Okay, and so it's like listening on what's supposed to do. So you push it, and then emit is what
Unsubscribe. You want something to no longer listen.
basically,
So
yeah,
take off.
take it off.
Out of the array.
I can think of two different ways that you could do it. One is to do just like, so you could push, if you're going to push a class, but another way that might be better and more in line with functional programming is just to return a filtered version that doesn't have it. That's how Redux does it.
Subscribe, return.
Yeah, so what it returns itself is a method that unsubscribes. The unsubscribe method is what it returns. Okay. And that's exactly what Redux does actually.
Okay, but so in this library, it makes it so that
In this library, not you, is what you mean by library.
in RxJS
I'm not sure we're using RxJS.
I know, but I'm just saying that in this case, when you subscribe, it returns
It returns the unsubscribe function, the unsubscribe method.
Isn't that in Redux?
Yeah, that's what I'm saying.
But in this,
exactly like
but in
that.
this library, it's not.
But I don't know what you mean by library. This is just Java.
No, this is a real library. RxJS.
Oh, yeah, but what I'm saying, but what we're doing is we're defining, we're writing the class observable.
I know, I'm just trying to understand how it works in this library.
I have no idea because I don't know what observable is, other than the function as we described, other than the classes we're describing.